Okay guys, so we'll do a quick video on the worked solutions from your textbooks. This is just quickly finding some of those areas under the graph, right? So I'll walk you through how I would do these problems and hopefully it'll help you with some of the homework questions. Okay, so if we have a look at the first worked example, 9.10, right? It says find the area of the shaded region, right? They've given us the equation of the curve, y equal to 3x squared, and they've asked us to find the area between 4 and 6. Okay, so we can basically say the area that we're asked to find, right? Well, we've learned that this is just the sum of all those tiny little areas, right, of this function 3x squared with respect to x. Okay, so at this point we would have had two paths we could have gone. We could have either worked out the area itself, or we can use the primitive to find the area out. Now if we have a look at the graph, we can see it's a curved graph and we don't have any kind of equation to work out the area for a curved area. So we're going to use the primitive function. Okay, so the very first thing we're going to do is we're going to anti-differentiate to find the primitive function. So if I anti-differentiate 3x squared, I'm going to raise the power by 1 to 3, divide by the new power. That's just going to leave me with x cubed, right? And I want the area between 4 and 6. Okay. Right, so we basically want to take our new function between 6 and 4, and we're going to subtract them. So we're going to take f of 6, take away f of 4, right? This is going to give me the area that I'm after, right? So let's just plug in 6 everywhere we have an x. We have 6 cubed, there's my end, take away 4 cubed, there's my start. Okay, this is going to give me 216, take away, what did we have, 64, and that's going to give me 152, right? And because we're talking about area, this is some units squared. Okay, so nice and easy one to start off with. Okay, all right, let's fetch the next one. Okay, the next worked example, 9.11, says find the area of the shaded region. They again have given us an equation, y equal to x squared minus 6x, and they're asking us to find the area between 0 and 6. Right? Now, they didn't specifically give us the values, but you can work out that the curve and the shaded area pass through the origin at 0, and it cuts through at the x-axis at 6 again. So you would have had to use some intuition there to work out it's between 0 and 6. Okay, so let's take the area again that I'm asked to find is just the sum between the limits 0 and 6 of my function, and this time the function is x squared minus 6x, and that's with respect to x. Okay, so again I can look at this and I can say, can I find the area of this by itself? And the answer is no, and so I'm going to use the calculus technique by finding the primitive, right? So this is where we need to now anti-differentiate. So to anti-differentiate, I'm going to raise the power by 1 and divide by the new power. I'm going to raise the power by 1 and I'm going to divide by the new power. So I can just tidy this up a little bit. Let's tidy this up. This is going to give me x cubed over 3 minus 3x squared, right? And I want this between 0 and 6. So let's punch the numbers in. I want to take f of 6 because that's my end, and I want to take away f of 0, that's my start. Everywhere there's an x, I'm going to put 6 now, so I'm going to have 6 cubed over 3 minus 3 times 3 squared, and I'm going to take away f of 0. Now I can see that all my terms have an x in it, so I'm going to get 0 over there, right? Right, if we, I'm just going to get my notes here. If we take this area, we're going to get 72 minus 108, take away 0, and this is going to give me an area of minus 36. Now, this is where we have to be very careful. We were not asked to find the integral. In other words, we weren't asked to find the signed area. We were asked to find the area under the graph, right? So area can't be negative, right? And so we will just make this area positive, right? So in other words, the area is just 36 and units squared, okay? So that's where it's important that you read the question. If that asked you just for the integral between 0 and 6, right? In other words, the signed area, the total displacement, right? It would have been negative 36. But they're asking us for the area, in other words, the total distance traveled if we were talking about velocity, okay? Okay, let's grab the next one. Here we have find the total area of the shaded regions, okay? And this is the first time where we have to look at the problem and be very clever and cautious about the way that we deal with this, okay? We can already see from the graph that we're going to get a positive, okay? We're going to get a positive area at the top, and we're going to get a negative area at the bottom. Now, if I take the integral between 0 and 6, and you can do the maths for yourself, it's going to give you the combined area of those two areas. In other words, it's going to take the positive area and it's going to subtract the negative area, and it's going to, as you can see, the negative area is smaller, and so you're going to get quite a large negative area, right? Now, we don't want the signed area, we want the total area. In other words, we want to evaluate these two things separately from each other and add them together. So in other words, we're going to evaluate that negative area, find out what it is, make it positive, and then add it to the other area, right? Another way we can think about this is we're actually just going to subtract that negative area, because if you subtract a negative number, it will change signs and become positive, okay? So this time, the area is not, so I'm just going to write here, for your sake, is not the total area. So I'll even write here total area is not equal to the integral between 0 and 6 of my function, right? F of x by dx, right? That would give us the signed area, all right? And you can go and do the maths for yourself, right? Do that from 0 to 6 and you'll see you're going to get a completely different answer to the one that we want, okay? So in this question, we need to take these two areas separately. We're going to take the integral of both of them, right? In other words, it's the integral from 0 to 2 of my function. Oh, okay, well, I have a look here and I see that this function is not something that I can work with yet. So why don't we, before we even do this, let's convert this into something that I can anti-differentiate. Okay, so here we have y equal to x minus 2, x minus 6, right? I'm going to do the brackets first, and then I'm just going to multiply everything by that lonely x on the outside. So I'm going to get x squared from the first, right, which is just going to become x cubed, right? Minus 6x minus 2x gives me minus 8x, but that's going to be minus 8x squared. And then I have minus 2 times minus 6, which is positive 12. And we have that x hanging on there. So there's my function. Okay, so now we can find the area. So the area, or the total area, sorry, is equal to the integral from 0 to 2 of x cubed minus 8x squared plus 12x dx, okay? And I'm going to say minus, right, because I know that the next area is going to be negative, minus the integral from 2 to 6 of x cubed minus 8x squared plus 12x with respect to x. Okay, that'll give me the total area, not the signed area. Okay, again, you need to think about this as either total distance traveled or total displacement. Okay, they are two different things, right? Even if you're going backwards, you're still traveling a distance, right? And if you travel the same distance forward again, your total displacement might be 0, but you've actually moved, right? The distance that you've covered is something. So this total area that we are working on is the total distance if you were working with a distance time. Okay, we need to anti-differentiate and find the integral. So this is where I said keeping track of things is very important. You can see that these terms, they can start getting messy. So we really need to pay attention to what's going on. Okay, so I'm going to create my two primitive, the primitive function is going to be the same. So I'm just going to, let's get the first one. Okay, I'm going to take x to the power 4 and divide by the new power. And then I have minus 8x. I'm going to raise to the power 3 and divide by the new power. And then 12, I'm going to raise to the power 2 and divide by the new power. And this one is between 0 and 2. And I'm taking away, unfortunately it's the same function, so we can use the same primitive, minus 8x cubed over 3, and I'm going to just simplify that into 6x squared, seeing as 12 divided by 2 is just 6, and this one is between 2 and 6. Okay, so this is where things can start getting messy. All right, so you've got a lot of arithmetic to do now, so be diligent with the way that you do this. Here we go. So we're going to look at this first one first, okay? The 0 to 2. So the end is 2, so I'm going to have 2 to the power 4 over 4. Take away 8 times 2 to the power of 3 over 3 plus 6 times 2 squared. Okay, that's my start. And I can see I have an x in each of these terms, and so I'm going to be taking away 0 for that one. So there's my first integral. Okay, here we go. Here's the second one. We're starting at 6, and we're going to take away 2. So we're going to have 6 to the power 4 over 4 minus 6 cubed over 3 plus 6 squared. Okay, that is just the first half, and we need to take away 2 to the power 4 over 4 minus 8 times 4 cubed over 3 and plus 6. Sorry, these are not 4s, these are supposed to be 2s. Let's do that one again. See where this gets very, very messy otherwise. Take away 2 to the power 4 over 4 minus 8 2 cubed over 3 plus 6 2 squared. Okay. Right, so we're going to punch all these into the calculator, and fortunately for us, this has already been done with us, and we're going to get, I believe, for the first one, 6 2/3. And for the second one, we're going to get negative 42 2/3. Okay? And you can see that if I take a negative and a negative, this is what's going to cancel out and give me the positive and give me the total area of 49 1/3, and this is units squared. Okay. So I've skipped out a lot of the calculations. You'll see in the textbook that they've gone one step further. You use as many lines as you need. Just be very diligent, right? And make sure that you keep track of all your minus signs, substitute incorrectly. You saw I made a mistake there by substituting in the wrong figure. Okay, so this is why this stuff gets messy. So you need to be very careful with the way that you do it. Okay, let's look at one more. And this is now going to be, in this question, they've asked you for the area not between the curve and the x-axis. They've asked us to look at this between the curve and the y-axis. All right. So the way that we do this is just going to be slightly different. Now, if this equation was y equal to something, we would have had to change it into x equal to something. Okay. I'm going to just off on the side here because we can't do anything with this guy. We're just going to change this into something we can work. This is going to be 4y minus y squared. That's my equation, right? The area this time is not equal to the integral from 0 to 4 of f of x, right? It's f of y, and f of y is just this equation x equal to, right? In other words, 4y minus y squared with a tiny little change in y this time, right? So that instead of our little areas being vertical, we're taking lots of little horizontal areas and adding them up, right? As that little change becomes closer and closer to infinity, okay? So from here, we can just anti-differentiate, right, in terms of y this time. So let's get our primitive. We're going to get 4y. If we integrate that, we're going to raise to the power of 2, divide by 2, and so I'm going to be left with 2y squared minus, and this is going to be y cubed on 3. Right? This is between 0 and 4. Right. Now we just need to plug in the values. The same thing applies. This is the end. This is the start. Okay, so I'm going to take f of 4, take away f of 0. So we have 4 squared minus 4 cubed on 3. That's my end. Take away, well, we have 0. So we're going to have 0 take away 0. And this is going to give me, let's have a look here. This is going to be, if we have a look in the textbook quickly. Well, let me get a calculator out and work this out. So we have 4 times 2. 4 squared times 2 is 32. Take away 4 cubed. This is take away 64 on 3, and that's going to give me 10 2/3. And this is units squared. So hopefully that will help you guys with the homework questions, right? Be mindful that we can be asked to find the area between the curve and the y-axis. So we need to have an equation x equal to something. We're always used to having it y equal to something. So if we're thinking about it in the other direction, it just needs to be x equal to something. And then very importantly, if we're asked to find the total area, remember that area, the integral gives us the signed area. And so if we want to find the total area, we need to be able to isolate those areas above and below the graph, right? And this is why it's always important, if you're not given a graph and you're asked to work out total area, you need to draw a graph. You need to see where those x-intercepts are, because you need to know what part of the area is above the graph and what area is below the graph. If you were just asked to work out total displacement, well, then you could just take the integral as is, right? That's how far am I away from my starting point. But if I want to know exactly how far I've traveled, Well, I need to know all those separate areas and add them together. All right. So I hope that helps you guys, and I'll see you tomorrow.